Welcome to Mastering Machines, where we discover tomorrow's reality.
Hello, everyone. Welcome to Mastering Machines, where we discover tomorrow's reality. This past week, we had one of the most stunning technological developments that I've probably personally ever seen in my life, and that was the Neuralink. Let's cut to the footage of this momentous occasion. This has definitely confirmed to me that we're officially in a new age. As this audience probably knows, Neuralink is the brainchild of Elon Musk. This past May, Neuralink, the brain implant venture spearheaded by Elon Musk, announced that it had received its regulatory clearance to commence its inaugural clinical trial involving human participants. It secured an approval from the U.S. Food and Drug Administration, and it represented a really significant achievement for Neuralink. The company has been diligently working on a groundbreaking device designed to be surgically implanted into the human brain using robotic assistance. This device boasts the remarkable capability, as you see from the footage, of deciphering neural signals and establishing connections with computer interfaces. Prior to this milestone, Neuralink's research endeavors were solely confined to animal studies. It was only 1 month ago when it was announced that the first patient of Neuralink had a successful implant of the device into his brain. Now I want to talk about the deep tech of the Neuralink chip and what goes into it, what it's consisted of, and how it actually works. One of the main components of the Neuralink is the N1 device. And this continuously is using a battery. When the battery runs low, it can be charged using a wireless power transfer. However, unlike many consumer electronic devices, which can use a physical connector for charging, the N1 device faces several unique challenges due to being fully implantable. There's no magnets for alignment, ensuring that the system can operate over a wide charging volume without relying on the perfect alignment with magnets. They also have a feature that's called dynamic tuning, which basically powers the efficiency of the chip, so it's always getting better. Also, let's talk about how the Neuralink stands the test of time. One of the most interesting things that I read regarding the Neuralink was that it has a system that mimics years of wear and tear in just a fraction of the time. So it gets a sense of what issues that might come along. And then also they're keeping an eye on moisture levels to prevent any type of electronic hiccups that might cause the Neuralink from malfunctioning or anything like that due to moisture or wetness or anything like that. So the N1 chip is the key component of Neuralink system, and it has neural recording and stimulation capabilities with high bandwidth and real-time data processing. Also, it has what's called an analog to digital conversion. It basically allows a neuron from analog to digital, which involves amplifying and filtering the neural signals before converting them into digital data for processing and allowing that person to actually control that. Then there's the automatic spike detection. Neuralink employs methods like directly characterizing spike shapes for robust spike detection, crucial for brain-machine interface tasks. So it basically has automatic detection to see like abnormal or over-the-top spikes within brain activity within that particular patient of the Neuralink. Also, it has data compression and transmission that is over 200 times enabling faster than data processing and transmission through a single USB-C connector. So that's the connector that you'll find on your iPhone. And also, in regards to the N1 chip, It can stimulate electrodes in groups of 64 simultaneously, enhancing the performance for complex tasks requiring a lot of neural stimulation. And what you'll see from a lot of the people that are looking at the tech of the Neuralink is the actual chip architecture. And the chip architecture has its ASIC. The ASIC chip within Neuralink system consists of various components like analog pixels, ADCs, multiplexers, controllers, and compression engines to manage neural data effectively. So basically, a lot of these components are making the chip run really efficient and allow it to transmit it and compress a lot of that information in record time. Then there's the circuitry. The circuitry acts as a conductor for orchestrating those ASIC components that I was talking about just earlier. It allows for programming via the scan chain paths, which is basically what that particular chip is looking at as far as the brain activity, and then it allows to configure the chip's parameters and modes. And you can see that Elon has really made it his mission to use Neuralink to kind of get a lot of disabled people using their limbs again and being more active as far as within their lifestyle and being able to control things that they usually couldn't due to whatever disability that they have. And it seems like that's going to be the way of the future, where Neuralink might be powering, robotic limbs, robotic legs, or even, monitoring whole entire factories by controlling your mind. We are entering a new age, and the Neuralink is just one building block of this possible age of abundance that technology will create and AI will create in the next 4 to 5 years. So with that, this has been Mastering Machines. Remember, discover tomorrow's reality.